All right. Welcome to lesson 10.9. We're going to be continuing to sort of practice with and discuss and talk about Taylor series to get better and better and better at using and applying Taylor series. Okay. I first want to say that I'm very proud of all y'all's hard work. This week, the questions you've asked, given our difficult circumstances, I have been very relieved at the amount of I don't know, participation and enthusiasm you have shown. I know it's difficult, and we kind of don't know what the next couple weeks really look like in terms of other struggles we might run across. But I appreciate all your devotion so far. I really do. Okay, so let's go ahead and jump into things. I want you to go ahead and take, let's say, 2 minutes or so to do these two warm-up questions. Pause the video, try them, and then come back and check your work against mine. All right, so we have let p of x be this polynomial here, and it's the fourth degree Taylor polynomial for the function f about x equals 3. Can f of 2 be determined from the given information? Explain your answer. Now this is kind of interesting. Can f of 2 be determined? That sounds like we're talking about, like, can it be determined exactly? So the answer here, can we exactly determine f of 2? No. Ooh, thought I'd switched over to my thinner pen. F of 2 cannot exactly be determined, but we have some other comments I want to make about this. The answer here is no. F of 2 cannot be determined. Now, we could approximate f of 2, we could approximate f of 2 if p of x is the fourth degree Taylor polynomial for f about x equals 2. We can maybe approximate f of 2, but we can't determine f of 2. Another thing we could think about, if this question had been a little different, we could say, like, what about like f double prime or f triple prime of 2? You go, couldn't I look at the coefficients here? Couldn't I look at the coefficients here for f double prime or triple prime or fourth prime of 2? The answer here would be no, because the coefficients here would come from f double prime, triple prime, quadruple prime of f of 3, because that's where we're centering it. So this 2 is going to actually throw us off kind of no matter what, depending on the question we are looking for. Okay, this polynomial is centered at x equals 3, so f of 2 can't really tell anything specifically about it. Now f of 2 cannot be determined because the Taylor polynomial is written about x equals 3. Maybe the best way to explain that. All right. Using the information above, what is the value of f double prime of 3? Aha. So this one is asking about something at 3. So let's see, f double prime of 3. I'm looking there, okay, f double prime of 3. Where does that mean I need to look? It means I need to look at the coefficient of the x power that's squared, because that'll match up with the double prime. Okay, so again, what is our Taylor sort of series formula? This is one of our important ones we got to remember. The Taylor series formula is f, sorry, I had a little pin freak out there for a second, is the kth derivative of f at a over k factorial times x minus a to the k, right? Remember doing that over and over again last lesson? Okay, f double prime of 3, I'm going to look at the squared power here, so 6 is going to be this coefficient term here. X minus a is 3 is that part. So I can say the second derivative of 3, remember k is also our factorial, 2 factorial is going to equal 6 that I'm seeing sit in front there. 6, which is sitting in front, 6. So what does this mean for us? this means that if I multiply both sides by 2 factorial, I'll get f double prime of 3 equals 6 times 2 factorial. 2 factorial is just 2, so that is 12. F double prime of 3 is 12. Okay? Well, so just some more of us to get us thinking, get some ideas back in our minds. A few comments before we move on, okay? There is going to be a quiz on Wednesday, so next Wednesday, on remembering your important Maclaurin series. As we'll see in some of our free response questions today, just memorizing each of these series is really crucial, right? This will help speed up a whole lot of things, especially because sometimes they literally just ask you to write the first 4 terms of blank. And you could do all the derivatives if you wanted to, but that gets really annoying. It's worth just memorizing each of these to kind of spit them out. What they're approximating, the power series, and the summation notation of that series, okay? So we'll actually return to this today occasionally so you can see just how important it is, but I'll basically give you these things and you have to write out the rest of it on the quiz, okay? Here we go, let's take a look. Cosine of x minus 1, sorry, f of x is cosine of x minus 1 over x squared for x is not 0. When x is 0, negative half. All right, the function f is defined above. It has derivatives of all orders. Okay, it's got all its derivatives. Let g be the function defined by, okay, g is this function here, 1 plus the integral of f, which I see up here. Write the first 3 non-zero terms. Okay, here's some crucial information. We're looking at the first 3 non-zero terms and the general term of the Taylor series for cosine of x about x equals 0. Let's just stop there. Wait a minute. This is exactly what I was talking about. So when we say, wait, cosine of x, I see it in here, but we just want the Taylor series for the cosine of x. That's why it's important to just memorize these things. If we remember that our cosine of x Taylor series is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, then this actually becomes fairly easy to do and accomplish, okay? So in part A here, in part A to actually do this, we can simply recall that cosine of x, the Taylor series is going to be, okay, 1. All right, 1, and then we remember going up here, just to remind you, right, minus x squared over 2 factorial plus, and so on, minus x squared over 2 factorial plus, next one is positive x to the 4th over 4 factorial. The cosine ones, we kind of use only even things here. 0, power 2, 4, 6, and so on and so forth. Plus, our notation needs to be solid here, plus, dot, dot, dot. Well, I guess we should say minus, because the next term would be minus, wouldn't it? Minus, dot, dot, dot. And then it says we need the general term too. So minus dot, 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 plus our general term here is negative 1 to the n. I know we've not talked a whole lot about creating the general terms, but each of these, after we've eliminated the 0 terms, because notice we don't have an x or an x cubed or x to the 5th because those coefficients are going to be 0. In our general term, we still count this as the 0th term. So if you want to, you can think n equals 0 for this one, n equals 1 for this one, n equals 2 for this one, okay? So negative 1, starting at our 0 term, that needs to be positive, so it's negative 1 to the n. And then x to the 2n, I know this is in the memorizing formula, the formula I want you to memorize, but I'm also going to explain this, x to the 2n, because if this is n equals 0, x to the 2 times 0, x to the 0 will give us 1. Then our n equals 1 needs to be 2, n equals 2 needs to be 4, so we need to multiply n by 2 over that 2n factorial to get the denominator there. Okay, so we did I underlined the wrong thing now, didn't I? So we just wrote out the first 3 non-zero terms and the general term of the Taylor series for cosine of x. That's what we just did there. 3 non-zero terms, general term, Taylor series for cosine of x about x equals 0, the Maclaurin series. Use this series to write the first 3 non-zero terms in the general term for the Taylor series of f. Okay, so we want this thing up here now. Okay, so I want to call it like, we'll just say that like f of x then. I guess we could have also, if we want to, because this really is approximating cosine of x. All we're doing is basically recalling the formula. I'll switch that over to cosine of x. Okay, for our function, which will be f of x, let's see how it differs. So, we know that our first term for our f function is going to be f of 0, which is here. Now, f is also defined as the cosine of x minus 1 over x squared, right? So we can go, okay, cosine of x minus 1 over x squared. I already have my whole formula here, right, for cosine of x. So the rest of this, then, I can kind of just build off of this. Kind of think about it this way, maybe. The cosine of x formula I already know. It's right here. And then I need to take that cosine of x. I need to subtract 1 from it. So if cosine of x I know is this, cosine of x equals 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus etc. etc. I want to subtract 1 from this, so that's cosine of x minus 1. It's going to be equal to, I'm going to subtract 1 from this, but that's easy to do. It'll leave me with negative x squared over 2 factorial plus x to the 4th over 4 factorial, because I subtracted that 1 basically to the side. I'm trying to build out this formula up here. And then I can say, okay, cosine of x, if I divide everything by x squared now, divide everything by x squared over there, what I would get then is the cosine of x minus 1 over x squared is equal to, I'm going to divide all these by x squared, so that'll give me negative, let's see, divide that by x squared, that'll be negative 1 over 2, plus, divide this by x squared, that'll give me x squared over 4 factorial. Remember the next term over here, if we wanted to, would have been x to the 6th over 6 factorial plus, and so on and so forth. So I'll go ahead and add that over here, minus x to the 6th over 6 factorial, because it wants us to write the first 3. So I'm going to divide this one by x squared also, so that'd be minus x to the 4th over 6 factorial. Alright, and so actually this over here, I'm going to go back and actually make a correction that I was probably explaining something not a great way. I want to get rid of this because really what we just did is we built out then the series for f here, because when x is 0, notice our first term is negative half, so that matches up with this. So we could ignore what I had said over there earlier. So here then, just building it off of knowing what cosine of x is, subtracting 1 divided by x squared is our series for f of x. And then it would be plus so on and so forth. So let's actually get that over here, come up with a general term. So that'd be negative half plus x squared over 4 minus x to the 6th over 6 factorial. Remember it says the first 3 non-zero terms, so that's what I just did there. All right, plus, etc., etc., plus. Now we need the general term. Okay, it starts with a negative 1, and this is going to be the 0th term. So let me do negative 1. If that's the 0th term I want to stay negative, I can say n, which is 0, and that first term plus 1, because that'll make the 0th term negative. And then notice our pattern here. Our first term is squared. Our, ooh, I copied down the wrong thing, didn't I? That should be x to the 4th over 6, because we divided by x squared. Notice our powers, they are still counting up by 2, so this I can still say is x to the 2n. Here n is 1, and our power was 2, so it's 2 times n. N is 2, so 2 times 2 is 4, and so on. Over, we have 2, 4, 6. This is going to be a little different this time. Notice that at our 0th term, we start with 2. So start with 2, and then we're counting by 2 every time. Oh man, I lost a factorial in there also. That came from over here, didn't it? That this down here needs to be 2n, because I'm going to count by 2 every time n goes up. But I'm going to start at, when n is 0, 2 already. So 2n plus 2 factorial down there. All right, so there we go. There would be part A of that one. Sorry about the little glitch in the middle. I'm going to hopefully cut that out. If you didn't notice the glitch, then great. It means I cut it out. All right, let's move on to part B. Part B, use the Taylor series for f about x equals 0 found in part A. So we just found that about x equals 0. I'll rewrite it down again just so we can see it, because we will need it. F of x, we just found out, was -½ plus x squared over 4 factorial minus x to the 6th over 6 factorial plus so on and so forth plus -1 to the n plus 1 times x to the 2n over 2n plus 1, sorry, 2n plus 2 factorial. I should have also said, if you could go back up and add it, that technically that last thing we wrote out should have plus ellipses, and the same thing with that initial cosine Maclaurin series. We need, because it does keep going, so please add that to the cosine of x Maclaurin series and the one we just wrote for f of x. And B says, use this to determine whether f has a relative maximum, relative minimum, or neither at x equals 0. Okay, so this is interesting. We know to find relative minimum, maximum, things like that, we need to have stuff about critical points or concavity. And here's what I know. I would know that f prime of 0, because that'd be the first derivative. That'll tell me if I have a critical point at 0, and that'll tell me something about maximum, minimum. F prime of 0 is the coefficient, right? If I'm thinking about Taylor series, it would be the coefficient of my term with an x in it. But I know, hey, there is no term with an x in it. So what does this mean for me? If there is no x term up here, then that means f prime of 0 is 0. So I might have a relative maximum minimum. I know I have a critical point, because each of the coefficients in part comes from the derivative, and there's no derivative here at the x term, so that means the first derivative has to be 0, right? First derivative at 0 has to be 0. Okay, what else do I know? Well, I know in my second derivative related thing, I know that this coefficient, 1 over 4 factorial, is equal to the second derivative of 0 over 4 factorial, which I know is equal to 1 over 4 factorial, right? What do I know about this? It's positive, right? It's positive. So what does this mean? It means f double prime of 0 has to be equal to, I wrote the wrong thing, didn't I? That in our Taylor series, it's not over 4 factorial. Our Taylor series rule is that this would be, if this is the second derivative, over 2 factorial, and that's equal to 1 over 4 factorial, right? That'd be equal to 1 over 4 factorial, which means it's equal to 1 over 4 factorial, which means my second derivative, after I multiply 2 factorial to the other side, would be 1 over 12. So look, I know my second derivative based off of kind of similar to that warm-up problem. 1 over 4 factorial is going to be equal to the second derivative, because it's going to be the x squared term over 2 factorial. So the second derivative is 1/12. It's positive. So what does that mean? I know my second derivative is positive. I can say because there, what can we say? Because there is a critical point at x equals 0, and the second derivative at 0 is positive. What does that mean? It means our graph is concave up, and we have a critical point. Therefore, you can say by the second derivative test, if you want, it's called the second derivative test. We can say, therefore, f has a relative minimum. Keep in mind that the coefficients here are really telling us about the derivative. There is no first derivative coefficient, so it's 0. First derivative is 0. The second derivative coefficient has to be positive. Second derivative is positive means concave up. First derivative 0 means we got a critical point, so it has to be a relative minimum. That's called the second derivative test. All right. Cool. And let's look at part C. All right. I'm going to look at part C. I am going to I'm just going to erase certain things because for part C, we actually need some more of stuff about F again. Okay. So for part C, we're asked a different question, but an interesting and important question nonetheless. Get rid of all that. Okay. Part C says, write the fifth degree Taylor polynomial for G about x equals 0. Okay. Well, G is this function up here. I know that G of x is 1 plus the integral from 0 to x of f of t dt. Look, I know all of this stuff about f already. So that means G of x, whatever it's going to be, is going to be equal to 1 plus the integral, the antiderivative of all this f stuff. So let me take the antiderivative of all this stuff, and let's just see how it looks, and then we can do the other stuff. The antiderivative of f, the antiderivative of negative half would be negative half x, plus, I would add 1 to the power, that'd be x cubed, divided by, it would still have the 4 factorial, but I'm going to divide it by the new power, so it's 3 times 4 factorial. That looks like a minus now, but 3 times 4 factorial. All right. Minus, I would add 1 to that exponent there. Oh my gosh, I wrote the wrong thing down last time. I am all bad about all this stuff today. So in part B, I had the wrong power. There's so many little things we got to keep track of. It's good to catch them, though, as you work. It's good to catch them as you work. All right. Minus, let's see, x to the 4th. I need the antiderivative of x to the 4th. So that'd be x to the 5th. I would divide by that new power, but there's a 6 factorial down there I'm going to keep as well to make sure that I have preserved the original thing. Plus, and so on and so forth. So it actually already looks like we're at the 5th, because we want the 5th degree. We're already at the 5th degree. I'm sorry about all these little mistakes. Go back and fix that power there in the previous problem. It didn't impact our answer, but I did write it down incorrectly in part B. Our f polynomial should be x to the 4th over 6 factorial. All right, so there we go. I've done the antiderivative. I'm going to evaluate this at 0 and x now. 0 and x. So think about it. If I plug in x stuff, this should be, I did the antiderivative with respect to t. Another little mistake, all these little things. Technically, the variable here is t right now. Sorry, y'all. T. I'm going to evaluate at x. I'm going to plug in x. And I'm going to plug in 0, but when I plug in 0, I get a bunch of things that are 0. So this actually becomes really easy to write out then, that this g function is going to be 1 plus what I get when I plug in x. So plus negative 1/2 x. So that'll be minus 1/2 x plus x cubed over 3 times 4 factorial minus x to the 5th over 5 times 6 factorial plus so on and so forth all the way down. So this would be our 5th degree Taylor series, but we want the Taylor polynomial, the 5th degree Taylor polynomial. So I'm going to write this out as p sub 5 of x, which would be 1 minus, we can simplify that to x over 2 plus x cubed over 3 times 4 factorial minus x to the 5th over 5 times 6 factorial. Here's my 5th degree Taylor polynomial. Okay? Right. So that's 3 parts of a free response question that we have seen before on the test. And notice it asks a variety of skills and different kinds of thinking. Some that we've not really seen before, like this new one where you have to think about the coefficients and what they mean. I apologize for all the little mistakes in there. Let's look at one more example. of free response question related to Taylor series. Please make the little corrections that I did do in there as I worked. It's good to catch corrections, and hopefully me catching the corrections reminds you of some important things as well as we go. I apologize for my lack of accuracy. All right, let's look at one more example. Okay, here we go. Looks a little different. This time we're given a graph. Let's see. Let f of x be the sine of x squared plus cosine of x. The graph of the absolute value, the fifth root of x, is shown here. Write the first four non-zero terms of the Taylor series for sine of x about x equals 0. Wait a minute. That's another one of the ones we got to memorize, right? Okay. Sine of x at x equals 0. That's the Maclaurin series. We just need to write that out. That's all they're asking for in this first one. And that's, in fact, just like one of the points is just knowing the Maclaurin series for sine of x. So we can say then sine of x based off of what I know and that I'm memorizing, right? You're memorizing these things, is x minus x cubed over 3 factorial. It's kind of the other parts of the series for cosine of x. The cosine of x one's all even powers and factorials. Sine is all odd powers and factorials. So minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7 over 7 factorial. So write out the first four non-zero terms, there they are, of the Taylor series for sine of x about x equals 0. That's the Maclaurin series. We did that. And then write the first four non-zero terms of the Taylor series for sine of x squared. Oh, well, if this is sine of x, then the sine of x squared, I would just substitute in my x squared in for these things. So I get x squared minus, let's see, that'd be x squared to the 3rd. So that'd be x to the 6th over 3 factorial plus x squared to the 5th. That'd be x to the 10th over 5 factorial, right? Minus x squared to the 7th. That's x to the 14th over 7 factorial. We just want to write out the first four non-zero terms of the Taylor series, but it's the series, so we're going to have it just continue like that. All right. Not too bad, huh? That's 3 points total for that. 3 points total just for being able to write out the two series here, the one you're supposed to memorize, and then the other one. If you ever forget this, though, you could go through the process, plug in 0, find the value, take the derivative, all that stuff like we've done the other days. All right, let's keep going. Let's see what part B says. Part B says, write the first four non-zero terms of the Taylor series for the... Oh, wait a minute. This sounds so similar. We just did sine of x. Now they want cosine of x. We've already used that one today. The cosine of x Taylor series is 1 minus... This is the one with the even powers, x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus so on and so forth, right? Look how easy it is to just get that point to just remember this series, 1 minus x squared over 2 factorial plus x to the 4th, 4 factorial minus x to the 6th over 6 factorial, and so on and so forth, just from memorizing that series there. All right. Now we need, it says, we did that. We did the Taylor series for cosine of x about x equals 0, first four non-zero terms. Use this series for sine of x squared we found in part A. So I should write that one down again. My sine of x squared series that I found ended up being x squared minus x to the 6th over 3 factorial plus x to the 10th over, that should be 5 factorial minus x to the 14th over 7 factorial plus so on and so forth, right? That was my series I found for sine of x squared already in the previous problem. All right, it says use this series to write the first four non-zero terms of the Taylor series for f. So here's f up here. Here's f up here. We want the first four non-zero terms of the Taylor series for f about x equals 0. Well, look, sine of x squared, I have that. Cosine of x, I have that. I basically just need to add these things together. So if I do that, sine of x squared plus cosine of x will be equal to, I can kind of go term by term. 1 1 doesn't have a partner over here, so I'm just going to write down 1 because I'm just adding these things together. 1 minus x squared over 2 factorial. That has a buddy over here. So for now, I'm just going to say minus x squared over 2 factorial plus x squared. X to the 4th does not have a buddy over here, so I'm just going to say plus x to the 4th over 4 factorial. Minus x to the 6th. X to the 6th does have a buddy over here, so I'm going to say minus x to the 6th over 6 factorial plus, plus a minus over there too. Actually, it's a minus x to the 6th over 3 factorial. How many terms do I want? I want to find the first 4 non-zero terms. There's 1. Those 2 will combine to be 2. Here's 3. There's 4. So this will take care of the first 4 non-zero terms of the Taylor series for f about x equals 0. I just need to combine the things that I can. So if I come over here, I can say then that the sine of x squared plus the cosine of x is going to be equal to 1. This is minus x squared over 2 factorial. I need a common denominator, so if I divide by 2 factorial here, I would get, so if I can think about this, I'm dividing by 2 factorial here, so I'm going to need a 2 factorial up top to multiply in. Then I have a common denominator. 2 factorial is 2. So if I do minus x squared plus 2x squared, I'll end up with plus, so minus x squared plus 2x squared will take me to positive x squared over 2 factorial. If you don't like doing that stuff in your head, just write out the numbers. This is x squared over 2 plus x squared over 2. Sorry, plus 2x squared over 2. So I end up with x squared over 2 over here. If you don't like the factorials, just write out the numbers. There's nothing wrong with that. Plus, let's see here, x to the 4th, he doesn't have anybody, so I'm just going to call it x to the 4th over 4 factorial. This is where things get a little interesting. I can kind of come over here and think, okay, I need a common denominator, x to the 6th. 3, what is it? 3 factorial. What is it missing to get to x to the 6th? It's missing, if I want to make this a common denominator, I need, so I have minus x to the 6th over 6 factorial minus x to the 6th. To get 3 factorial to look like 6 factorial, I need to take 3 factorial and multiply by 4, 5, and 6, right? 4 times 5 times 6. But if I do it down there, I have to multiply it up here too. 4 times 5 times 6. What is 4 times 5 times 6? 4 times 5 times 6. 5 times 6 is 30. Times 4 is 120. So that's going to be 1 x to the 6 minus 120 x to the 6. So combining the numerators here, negative 1 x to the 6 minus 120 x to the 6 will give me minus 121 x to the 6th over, now our denominators are both 6 factorials, 6 factorial right there. All right, and there is our series for f. Oh, we want the series, so it's not totally the series yet. We got to continue it out. There we go. A little tricky there, especially just taking care of like the coefficients and things like that. Hopefully you're able to get to the spot where I just kind of wrote out the combined, adding the terms together. And then take your time if you need to, write out your numbers so you can simplify your terms right. All right, and lastly, let me get rid of this. C. Find the value of the 6th derivative at 0. Well, we just wrote out, right? We just wrote out the derivative, or sorry, f of x, our Taylor series approximation, right? Which we found out from part B is 1. I guess we can even back up and see it, right? I'll write it out again. It was, as we saw, 1 plus x squared over 2 plus x to the 4th over 4 factorial, so on and so forth. So, in part C, we have 1 plus x squared over 2 plus x to the 4th over 4 factorial minus 121 x to the 6th over 6 factorial plus, and so on and so forth. And we're asked for the 6th derivative of f. Well, we know then if this is a Taylor series, 6th derivative, we need to look at this guy over here. And what do we know? We know that the 6th derivative of f at 0 sixth derivative of f at 0 divided by 6 factorial is going to give us these numbers that we see here in front of the x to the 6. So it's going to give us negative 121 over 6 factorial. Sixth derivative of f at 0 divided by 6 factorial gives me the numbers I see, including that negative sign, because typically series, we kind of think of the Taylor series as naturally positive. Now, solving for this, multiply both sides by 6 factorial, I can pretty quickly see that the sixth root of 0 is negative 121. And there's my answer here. The sixth root of f at 0 is negative 121. All right, hopefully this gives you some insight into sort of starting to dig into some of these free response questions. What you need to do for homework is to do the next 3 questions that I have on there. I want you to try each of the problems, preferably without notes. I want you to try, see how you do, and then use the videos I will post to score yourself and make corrections in a different color. I'll give you kind of a scoring key too. And make corrections in a different color to your problems. Then I want you to email pictures of your work to me so I can see it, and fill out the score reporting form by 6 p.m. Monday, March 30th. I'm going to put that form, it'll be up on my website sometime this weekend for you to be able to fill out and let me know how you're doing. Okay? Thank you for your time, and I'm sorry about some of my stutters and things here and there. Have a great weekend, everybody.